In the realm of science and epic privileged insights, the subject of what existed before the Big Bang has ignited mixed discussions and intrigued minds for quite a while. This monumental question doesn't just test how we might unravel the universe. It challenges the very limits of human knowledge. Imagine standing at the edge of existence, gazing into the vast shadows, and pondering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of history, space, and everything we know. Yet, was there a moment before? Could there have been a state of nothingness, a calm before the grand spectacle began? And if so, what was it? Or perhaps, was there something even more unsettling that existed before time itself? As we delve deeper into this inquiry, science takes us on a journey beyond the universe's starting point, into explorations that challenge our understanding. Physicist Brian Cox, known for his contributions to the wonders of the universe, suggests that something extraordinary might have existed before the cosmic explosion. He urges us to rethink our perception of reality and existence. In this discussion, we'll dissect the science, philosophy, and astonishing insights that might help us understand what existed before it all. We'll explore concepts like eternal inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astonish you, yet they could also open new understandings of our place in the universe. Prepare to dive deep into a realm beyond imagination, where science grapples with the unknown, leaving experts awed and sometimes even unsettled. Let's examine what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we first need to examine what the Big Bang truly was. The Big Bang, as scientists describe it, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to set the stage for the formation of all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this hot beginning, with galaxies spreading out from a single point. But why did this happen? And was there a time before this dense, hot start? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or tranquil. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like an enormous vacuum. Yet this vacuum wasn't entirely empty. It contained a tremendous amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it fundamentally laid the groundwork for everything that followed. In a fraction of a second, space expanded at incredible rates until the expansion slowed and the energy transformed into matter, particles, and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly create the universe? And why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially infinite Big Bangs and a boundless number of universes. Ours is just one of many. This massive, mind-bending reality challenges how we perceive the universe and leaves us with the question: what else is out there? The concept of nothingness before the Big Bang is speculative, not definitive. Even if you strip away all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an inescapable tapestry of something, even in its most vacant form. Even if we imagine stripping away these forces, leaving a dead space, the universe would still generate new forms of energy. This fact alone baffles scientists, as it suggests that true nothingness might be inconceivable within our understanding. Space itself has properties, rules, and constants that prevent it from being entirely empty. For instance, there's a concept called zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still briefly appear and disappear, creating a faint resonance of activity even in what should be empty space. This challenges our notion of a true void and suggests that, yes, even before the Big Bang, something existed that scientists are still exploring. One of the most fascinating theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible it could continue forever. Brian Cox describes an unimaginably vast inflationary multiverse where universes are constantly created and continue expanding. Imagine each Big Bang as a spark lighting another universe, while inflation occurs in various regions, creating countless other universes. This process could, in principle, go on forever. This idea of vast universes spawning others leads to a compelling concept of a fractal universe, where each new universe could potentially generate its own Big Bang. Each universe exists as a separate, self-contained space, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both thrilling and unsettling, as it suggests an infinite multiverse with no definitive beginning or end. Imagine our universe being just a tiny speck in a vast, infinite structure, constantly evolving and creating new universes. What if the disturbing truth is that there is no before or after, but rather an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not just a collection of matter floating in space. Rather, it is a complex network of energy fields that permeate the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear within these fields, temporarily gaining energy before returning it. This phenomenon produces virtual particles, entities that briefly exist and then vanish, leaving only a faint trace of their presence. The existence of virtual particles challenges the possibility of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you truly have nothing? According to quantum field theory, you wouldn't. Fields would remain active, sometimes creating transient particles. This constant activity in what should be nothing suggests that the universe does not adhere to our concept of emptiness. The existence of dark energy suggests that, even if our universe were emptied of all matter and radiation, this force would persist, continuing to stretch the fabric of spacetime. This leads to an unsettling question. If dark energy is a leftover from a previous state, could it hold clues to what existed before the Big Bang? Another perspective on the origins of the universe comes from the idea of quantum fluctuations. These tiny, random changes in energy levels within a quantum field might have been the seed that initiated the Big Bang. According to this view, the universe could have emerged spontaneously from a quantum vacuum, a state that is far from empty but instead teeming with virtual particles and fluctuating energy. If this theory holds, then the universe may have arisen not from nothing, but from a highly active quantum state. This challenges the traditional notion of a beginning and suggests that the fabric of reality may be inherently restless, capable of spontaneously generating entire universes under the right conditions. The concept of a multiverse adds yet another layer of complexity to our understanding. If our universe is just one of many, it raises profound questions about its origin and uniqueness. Could the rules and constants we observe, like the speed of light, the strength of gravity, and the behavior of particles, be different in other universes? If so, what mechanisms determine these variations? In an eternal multiverse, each universe could have its own distinct properties, shaped by the specific conditions of its Big Bang. Some universes might be inhospitable to life, while others could have physical laws so alien that we cannot even imagine them. This vast and diverse cosmic landscape forces us to reconsider our place in the grand scheme of existence. However, not all theories suggest a multiverse or eternal cycles. Some propose that our universe is part of a cyclical model, where periods of expansion and contraction repeat endlessly. In this scenario, the Big Bang might not have been the absolute beginning, but merely the latest iteration in an infinite series of cosmic rebirths. Known as the Big Bounce theory, this idea envisions the universe collapsing under its own gravity after a long period of expansion, only to rebound into another explosive beginning. If true, this cyclical process might leave subtle imprints in the cosmic microwave background radiation, the faint glow left over from the Big Bang. Scientists are actively searching for such evidence, which could rewrite our understanding of cosmic history. Yet another possibility is that our universe emerged from a higher dimensional realm. String theory and its offshoots, such as M-theory, suggest that our universe might be a three-dimensional brain floating in a higher dimensional space. Collisions or interactions between brains could trigger events like the Big Bang, creating new universes in the process. This idea expands our view of reality to include dimensions beyond the ones we can perceive. It also raises intriguing questions about what might exist in these higher dimensions. Could there be other forms of life or entirely different laws of physics operating beyond our comprehension? As we explore these theories, one thing becomes clear. The question of what existed before the Big Bang is not just a scientific puzzle. It is a profound inquiry into the nature of reality itself. The answers we seek may never be fully resolved, but the journey to uncover them continues to push the boundaries of human knowledge and imagination. What lies beyond the edge of the observable universe? Is it an infinite expanse of other universes, a void filled with quantum potential, or a realm governed by laws we have yet to discover? Each possibility challenges us to think bigger, question deeper, and embrace the unknown. Science may never provide definitive answers, but it offers us the tools to explore these mysteries with curiosity and wonder. Whether we are standing on the threshold of a multiverse, peering into the depths of quantum fields, or contemplating the timeless cycles of existence, one thing is certain. The quest to understand the origins of everything will remain one of humanity's greatest endeavors. All was available before the enormous detonation. Could it, sooner or later, have framed the circumstances that prompted the introduction of our universe? Could dark energy be the tranquil planner of expansion, or even the genuine start of our universe? As we investigate this possibility, we face the potential of dark energy not just as a force shaping our universe but as a key that could unlock the secrets of the multiverse itself. Another theory is that cyclic cosmology offers an alternative to the Big Bang as the ultimate beginning. It suggests that the universe goes through immense patterns of birth, death, and restoration. In this model, the Big Bang is not a one-time event but perhaps part of an eternal cycle where universes evolve, collapse, and then recover in another cycle. This theory implies that our universe may have been renewed from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning but rather a timeless series of universes emerging, developing, and restoring themselves over and over. Cyclic cosmology raises significant questions about the nature of time, as it suggests that time itself may be repeating rather than linear. If this hypothesis is correct, it could mean that what existed before the Big Bang was essentially another form of the universe, one that collapsed only to give birth to our current universe. For scientists, this hypothesis offers a rich solution to the question of extreme origins, suggesting that there is no obvious beginning. The universe has always existed in some form, transcending our notions of time and existence. Gravitational waves are another fascinating concept that could shed light on what existed before the Big Bang. These waves, first detected in 2015, are ripples in spacetime caused by the acceleration of massive objects, such as colliding black holes. Some scientists believe that these waves may have originated in the early stages of the universe during the Big Bang itself, or even before. If this is accurate, it could indicate that there was something that occurred before the Big Bang, an event or disturbance that set the stage for the creation of our universe. The idea of gravitational waves from before the Big Bang presents the possibility of detecting remnants from a time before time itself. Through our journey into the unknown, we find ourselves at the very edge of what is comprehensible. The universe, with its intricate web of possibilities, continues to expand beyond our grasp. Was there something before the Big Bang? And if so, what might it have been? As we continue to push the boundaries of science, we approach a point where mysteries remain dominant. What lies beyond our understanding may forever stay elusive, or perhaps one day we will uncover that before the Big Bang, the universe was merely one stage in an eternal cycle, a continuous march of creation and destruction where space-time and dark energy proceed endlessly. As we delve deeper into these cosmic questions, we find that the boundaries between known science and speculative theory often blur. One of the most intriguing aspects of the universe's origins is the role of quantum fluctuations. In the quantum realm, tiny changes in energy can lead to the creation of particles that seemingly appear out of nowhere. These fluctuations suggest that the fabric of the universe could have sprung from a quantum vacuum, a state full of potential, where energy is constantly shifting and fluctuating. This aligns with the idea of the universe being born from a quantum transition, perhaps driven by quantum fields that could have existed before the Big Bang as the initial spark for the creation of spacetime itself. In this scenario, The Big Bang can be seen not as a single explosive event, but rather as the beginning of a new phase in an ever-evolving quantum field. Some theories even propose that the observable universe as we know it could be just one in a series of bubbles or regions within a vast cosmic multiverse. Each bubble could have different physical constants and laws of nature. In this view, the Big Bang might not have been unique to our universe but part of an ongoing process of bubble creation within a larger multiversal structure. These bubbles could have formed as quantum fluctuations in the primordial vacuum, with each universe having a different outcome based on slight variations in its initial conditions. Exploring this further, we encounter the idea that the multiverse may not be entirely inaccessible to us. Some cosmologists believe that the possibility of detecting evidence from other universes exists, albeit indirectly. For example, they propose that there might be faint traces of collisions or interactions between our universe and neighboring ones. These traces could be imprinted on the cosmic background radiation or even in gravitational waves, as discussed earlier. Detecting such evidence would require advancements in our observational tools and technologies, but the possibility of discovering signals from other universes challenges our perception of ultimate limits. Moreover, parallel universes open up exciting avenues for understanding the nature of reality itself. If multiple universes can exist, each with its own set of physical laws, then the very definition of reality could expand far beyond our current understanding. It might also provide answers to long-standing mysteries, such as the fine-tuning problem. This problem questions why the constants of nature are perfectly suited for the existence of life. If a multiverse exists, with countless universes having different properties, it could simply be a matter of chance that our universe is one that supports life. As we grapple with these mind-bending possibilities, the role of dark matter remains another enigma in understanding the true nature of the universe. Dark matter, which constitutes a significant portion of the universe's mass, is invisible to our instruments yet exerts a gravitational influence on visible matter. Its origin and properties are still largely unknown, but it might be intimately connected to the fundamental forces that shaped the early universe. Some scientists speculate that dark matter could hold the key to understanding not only the moments after the Big Bang but also the very fabric of spacetime itself. Ultimately, as we push the frontiers of cosmological science, we are exploring not just the universe's past but also its future. The quest for understanding the origins of the universe, whether it comes from a quantum fluctuation, a cyclic pattern, or the mysteries of dark energy, may ultimately provide us with a deeper understanding of the nature of existence itself. This journey into the unknown is a testament to human curiosity and the relentless drive to uncover the hidden truths of the universe.